In the last video, we were talking about which way was our centripetal force pointing. So we said that our centripetal force was actually equal to our tension. The string is what caused the ball to actually move in a circle. So if I put the ball at a couple of different locations around this circular path, again, this is a bird's eye view of what's happening, and we think about which way the ball was moving at each of these points. Well, if we're at this point, we're moving to the left. Over here, we're moving down. Over here, we're moving to the right. Over here, we're moving up. We're going in this circular path. Well, in order to actually keep it moving in the circle, our string had to pull downward here on the ball to keep it on the path. Okay, over here it's the same thing. It had to move it to the right. It was pulling it towards the center of the circle to keep it going in that circular motion. Here it was pulling up, and over here it was pulling to the left. That is what actually caused our ball to stay going. And we will see that centripetal force will always point inwards. Now, some of you guys might be saying, wait a minute. I've sat in a car before and I make a turn, and as we're going around a turn, it does not feel like I'm getting pushed inwards. In fact, it feels like the exact opposite is happening. It feels like I'm going to fall out of the actual car. So if we scroll down a little bit here, what we're going to see is, let's pretend we are in a car and we are going to make a turn. So I'm going to draw just a portion of that actual turn. Okay, so we're going to say I'm in the car here. I'm driving forward. And I want to make the turn, so I'm going to turn around like that. And now my car is going to be going in this direction. As I said, our centripetal force is going to always point inward. So our centripetal force would be pointing inward at all times. But you feel like you're falling out of the car. You feel, as you turn, like you're going out like that. Well, the reason for this is simply because of inertia. At this point in time, your body is still going forward. So as you turn, the car begins to turn to the side. However, your body still keeps going forward until you run into the side of the car. The side of the car pushes you into the center of the circle, and that's what causes you to actually keep going in the circle. If the car door were open and we didn't have the car door there, you make the turn, you're going to start spilling out onto the ground and end up somewhere here, simply because a body in motion will stay in motion unless acted upon by an outside force. That is inertia. We've talked about that before. So your body is going to want to end up here. However, your car door pulls you inward. Your car door causes you to go around in a circle. Now, a lot of people tend to refer to this inertia, this wanting to tend to the outside of the circle, as something called a centrifugal force. In our class, we treat this centrifugal force thing as a swear word, simply because we know better. Centrifugal force is not really a force. The tendency to want to fall out of the car is simply this idea of inertia. So centrifugal force is simply inertia. It is not a force. I never want to hear you say it. To me, it's about the same exact thing as a swear. The next video will go through 2 practice problems and hopefully get us on our way to keep going.